DNO exists in the department or not. Referential integrity. Then entity null or not null. In case the not null, like the primary key, whether it follows such an integrity. Whenever you are doing such a operation, insert, especially insert, you need to check the such a integrity. In case of delete, what is the problem when you delete the data? For example, in this example, when you delete this one, any problem?
Yeah.
This one.
Well, yes.
You need to check the such a constraint. So, can I delete? Right now, no. You need to set the option. For example, this one should be changed, okay, to the default DNO. Or it can be null data. Okay? If this does not have any null constraint, it can be null data. Also, sometimes you can delete cascadely. When you delete this one, any referencing data will be automatically deleted. All of these options are implemented in the database query language. Later, you will practice such an option. There are different options. So there are different options. Reject or cascade or set null or set default is another option. Set default. Okay. Then also you need to check that when you update the data, you need to check whether null or non-null or primary key or foreign key. All the constraints you need to check. This is actually overhead. Because of such the overhead, many students, many actually designers, they ignore the foreign key. You should have the primary key to access the data fast. So, but the foreign key many of the times is ignored. But I do not recommend to ignore such a foreign key. So you should keep. Okay. So that is the end of chapter 5. That's I think pretty much we cover the 70–80% of the relational model. For details of the relational model, you can read the textbook. Also, it's a good idea if you have a time, read Dr. E.F. Code original paper regarding. Sometimes you cannot understand all the details, but it's also a good idea to read. It has been a while to read for me such a paper, but it's the very good starting point to understand the relational model.
On the slide 38.
38?
Yeah.
Yes.
There's a super SSN pointing
Yes.
to SSN.
Yes.
It's on the same relation. So how is it foreign key?
Yeah, foreign key. So think about the recursive, self-referenced the relationship in ER modeling. ER modeling, supervisor, supervising, supervising. Both of them are employed, but we can create the relationship similarly. It's not exactly the same, almost the same. So super SSN depends on SSN, which means before you create the employee, their supervisor should exist here. So when you insert the data employee, it's a nothing employee. You need to insert who is the first? CEO, who does not have any supervisor. Then next. So because of that, that's a good question. In the real project, they actually ignore foreign key first, then insert all the employee, then create foreign key later. That might be easier than creating foreign key first. Okay? In case something error and change the value or the manipulate, so then you can create the table with such a foreign key. Okay? Yes.
For the case of the CEO, since he doesn't have a supervisor, the foreign key would be...
At that time, it can be. This one can be null. Okay?
So when we point on the...
Null, you don't have to point. There's no way to find it. So, reference referencing, referencing can be the null if that doesn't have any reference to it. Okay, so that's the end of the chapter 5. The next, we're gonna have chapter. The next one is, I think that maybe next time we can. I will. So, from the information, we build ER diagram or ER diagram. This is called conceptual model. And also we talk about relational model to create the database. We will learn how to create the database using relational model. Okay. At that time, we are going to use the SQL database query language. Okay. They have the data definition language, data manipulation language. Using this one, we can create the database. So finally, we can access the data in the database using the application like the .NET or the some C# or Java and so on. The missing part is here. From here, ER model to relational model. So in the next class, we will learn how to. It's not actually creation. It's some of the students already realized some of the concepts are very similar. For example, the last example question, self-referenced one. What is that? It's a foreign key. It's quite similar. So we will see how to convert this one to this one. This is called the mapping. So mapping is a very straightforward way. Okay? There's nothing you can add or creativity. Just follow the direction step by step. So step 1 through step 8. But problem is, this is the ER model, conceptual level model. Not all the characteristics of the ER model can be applied to here. For example, what is that? For example, the super and subclass. Is it possible super and subclass here? No. Why? Because this does not allow any nested. Value should be atomic. So we will see how to convert this one into this in the next class. Then we'll continue for the relational algebra. Okay, thank you.